right, I'm joined now by Dr. Phil Klotzbach, Colorado State University meteorologist. He is the lead author on those hurricane seasonal outlooks that began a long time ago with the famous late Dr. Bill Gray. Phil has taken up the mantle on that, but he doesn't do it by himself. I'll let him talk about that a little bit here. He has a team that he works with, and they all compile this, and you guys know Dr. Klotzbach because of these seasonal outlooks. So what I wanted to do in this edition of Hurricane U is just kind of drill down as best we can and keep it as brief as possible as well on a few different concepts that I was thinking about. And so I figured you out there in the general public were thinking about too. So Phil, welcome to Hurricane U, Hurricane University, as I call it. Thanks for joining me. How's it going in Colorado?
It's going great. Thanks so much for having me, Mark.
So you don't do these forecasts all by yourself, right? There's a team that kind of work with you, and I mean, it has to be because these are pretty in-depth, you don't.
Yeah. So as you mentioned, so Bill Gray was the founder of the seasonal hurricane forecast. He started these all the way back in 1984. And so prior to when he started putting these forecasts out, there really was no way to know how active the upcoming hurricane season was likely to be.
Right.
And there were even Neil Frank back in the 1980s, who was director of the Hurricane Center, even said that there really was no way. But Bill Gray he was able to show using historical data that there was some predictability there. And he showed Neil, who was a director of the Hurricane Center, and Neil Frank was very intrigued by that notion too. And so our group at CSU has been doing it for almost 40 years now. And so Bill Gray started the seasonal forecast, and he had a bunch of different graduate students over time working on these forecasts with him, a couple other statisticians in the department. Unfortunately, Dr. Gray passed away in 2016. So I've actually been lead author on the forecast since 2006. I do work closely with a colleague of mine, Michael Bell, who's a professor in the atmospheric science department, as well as we have a graduate student, Jordan Jones, who's just about to get her PhD in hopefully about I think 3 weeks now, getting her PhD, just defending. So the three of us work closely together on the seasonal outlook. And I also talk to colleagues at other institutions as well. In addition to our group at CSU, we have a website, seasonalhurricanepredictions.org, where we have 25 different groups about 25 different groups that do seasonal hurricane predictions. So it's grown a lot. It's grown a lot since Bill Gray started doing these back in the early 1980s.
I wonder what he would think about how much it's grown, like, wow, there's a lot of competition, or would he welcome it? Like, hey, the more, the better. And maybe you can get a consensus out of it. Who knows?
Yeah. I mean, he always want to say, imitation is the greatest form of flattery, but also too, I mean, he was excited to see other people really getting interested in seasonal hurricane predictions, because again, there's approaches that I use, but just because that's what I use doesn't necessarily mean that's the 100% the way to go. There's other groups using other different techniques. There's statistical modeling, which is a lot of what we do, but there's also models from climate models, so forecasting the environment during the hurricane season using supercomputers. There's kind of these machine learning techniques that are being used. Wow. So there's definitely room still, I think, for improvement in seasonal forecasts, and I'm sure we can kind of get in to kind of talk about where we think seasonal forecasting, where it is, basically where it was when Bill Gray started, where it is now, and where it's likely to head in the next 10 to 20 years.
Well, before we get to the next 10 to 20 years, what's the update for the next 10 to 20 weeks or so? It's right?
Yeah. So we just updated our seasonal hurricane forecast, and we're now calling for a total of 20 named storms. We've already had 5, so 15 additional storms, 9 hurricanes. We've already had 1 Hurricane Elsa, so 8 additional hurricanes, and 4 major category 3, 4, 5 hurricanes. We haven't had any of those yet this year. That's an increase in our forecast from what we put out in early June, compared with the long-term average, which is about 14 storms, 7 hurricanes, and 3 major hurricanes. So somewhat above average hurricane season this year. And there's a few reasons. We were originally forecasting an above average season, and now it's even a little bit more above average than we thought earlier on. And we can go into a little bit of detail describing kind of why the bump up. I mean, obviously for the number of storms, one of the reasons for the bump up is we've had several more storms since the June forecast. And, when it comes to Elsa was a long-lived storm. It was a named storm for over 8 days, but the other storms have all been pretty weak and short-lived. And there are definitely an increasing trend in those, primarily due to just improved observational capabilities. We have better satellites, better observational techniques than we used to. So we are seeing more. The average 1991 to 2020 is what NOAA uses as their average, is 14, but it may even be a little more than that if we just say, look at the last 20 years. There was some really big observational improvements that came around 2000 that allow us to be able to detect some of these weak, short-lived storms that are storms, but just wouldn't have been named in the 70s, 80s, and 90s given the technology we had at the time.
And there's more people watching now with social media and websites like Storm 2K. Everybody's watching it all the time, so nothing's going to get past the goalie now. That's
That's correct. Yeah, I mean, and obviously too, you know, from a forecasting perspective too, there's so many more new techniques, and we could spend just hours talking about how, you know, what it was like when Bill Gray started doing seasonal hurricane prediction. And when Bill Gray started meteorology in the 1950s, basically a forecaster with hand-drawn weather maps could beat a computer weather forecast. So, you know, being able to forecast the weather a day out was a big thing, you know. So Bill Gray always said, like, one of the greatest developments during his time was numerical weather prediction. The fact that now we can predict the weather 3, 5, 7 days out and actually have pretty good skill, even as far out as 5 to 7 days. Even when I was a kid, you know, a 5-day forecast by day 5 was pretty marginal. And now, you know, 5-day forecast still have issues, especially if you look at places like Colorado where you get huge swings in temperature. But in general, you know, these forecasts do have skill, and we certainly see the same with forecasts for tropical cyclone track and intensity. Those have really improved in skill as well.
So in a nutshell, what has changed since April and May, June, that's allowed you to take this, you know, higher overall numbers? You know, what's changed?
Yeah, so we didn't really increase our numbers too much. We basically just bumped up by one hurricane. And our aggregate measure, which we use, is accumulated cyclone energy, which accounts for the intensity and duration of storms. So long-lived storms generate a lot of ACE if they're strong. Weak, short-lived storms, like the first 4 storms of this year, generate very little ACE. So we increased these numbers due to a couple of factors. One, the tropical Atlantic is a little bit warmer now in relation to the long-term average than it was, say, in April and May. Also, we're closer to the peak of the season, so now we're starting to monitor conditions, things like, say, like West Africa, since most of the hurricanes that we get in the Atlantic come from basically what are called easterly waves, of these big thunderstorm complexes that move off the coast of Africa. They have generally been very active. So we had Elsa, which formed from one of these waves. Hurricane Center also monitored 3 additional waves during June. That's a lot for June.
It is.
And so, you know, having that active West African monsoon, it's not necessarily a slam dunk that it's going to be an active season, but it does tend to load the dice more towards an active season. And the other thing is that normally early season storm activity really doesn't matter in terms of, I mean, it can matter in terms of its impacts, but it doesn't necessarily matter for the rest of the season. But if you get storm formations in the deep tropics, so say south of 23.5 degrees north, so in the official tropics, and especially in the eastern and central tropical Atlantic, that's typically a harbinger of a very active season. So Elsa tracking into the Eastern Caribbean, we only had 6 other years since 1900 with hurricanes in the Eastern Caribbean prior to the 1st of August, and all 6 of them were basically defined as hyperactive Atlantic hurricane seasons by NOAA. 2020 had one, and then the others were 1926 and 1933, which were both monster seasons long before most of us were around, but they were monster hurricane seasons. 1961 was also extremely active. And then 1996, which I'm sure people in North Carolina especially remember, was quite active there. And then 2005, which was pretty much active for everybody. So, you know, it's not to say that that's a sample size of 6, so not to say it's a guarantee, but it also tends to be another thing kind of loading the dice towards another active hurricane season.
Right. So, and I was going to ask about that. So Elsa being where Elsa was, and then, you know, before Elsa there was 95L, that was that strong easterly wave that had a lot of model support, especially from the Euro right off Africa. A lot of people, including myself, thought, wow, this is a huge signal, and it never really developed, but it was still pretty strong and robust, maybe even paved the way a little bit for what became Elsa. But then we had Elsa, and that was pretty far east, and it was not a very small hurricane. I think there was one, was it 2017 that we had Brett or whatever? It was just tiny down there, kind of in a small little, it's like, well, Elsa was a pretty big envelope of energy, proto Elsa, and then it developed and so forth. And I was thinking, this must be a pretty big signal here. This isn't usual. This isn't what happens at the end of June into July. So
I mean, you look at the satellite imagery from like mid to late June, and if you had, you know, if you just showed me a satellite image, I would have guessed it was like mid to late August. It looked more like something you would get that time of year. And like you mentioned, so in 2018, we had Beryl, which was this, I mean, it was one of those things like prior to satellite, probably wouldn't have known it was there because it was just, it was basically what they call like a midget. It was a tiny storm. And it was a hurricane. It was pretty potent, but it was very, very small. Whereas Beryl was a pretty big circulation. And that was a storm we probably would have even known was a hurricane prior to satellite, because they actually measured hurricane force winds on Barbados, on the island itself, which has obviously been populated for a long time. So also a storm that I think, we certainly would have known about, but probably would have also classified as a hurricane, even say 50 to maybe even 100 years ago. So again, not a slam dunk, but typically those kinds of things indicate that we are likely to have a more active season. So normally kind of so Atlantic hurricane season starts June 1st, but normally June, July in the deep tropics is pretty quiet. You may get stuff out, like kind of where we got a lot of our storms, something in the Gulf of Mexico, something off the US East Coast. Right. But the deep tropics are generally the vertical wind shear, which is a change in wind direction with height in the atmosphere, isn't necessarily super strong, but it's more basically what's called the thermodynamics. So the waters are kind of cold. Yeah. It's kind of dry. You get a lot of these dust outbreaks off Africa. Normally that's kind of what keeps the season from ramping up. And then it's the shear that kills the season late. Sure. Whereas, so if you get it in stuff in June and July, it means the thermodynamics are fairly favorable. So in this case, the waters were warm enough, there was enough moisture, right. And basically also formed pretty far south. It was, I think it formed like 9 degrees north, which is where the waters tend to be pretty warm this time of year. So it formed in a pretty healthy environment and was a pretty robust circulation. And again, it survived for quite a long time, over 8 days. And if you look historically, also at July storms that lasted 8 days or longer, they all happen in pretty active Atlantic hurricane season. So kind of however you slice it, Elsa, at least, one storm isn't guaranteed, but it does tend to also load the dice, in addition to the large scale circulation also looking a bit more favorable.
And so that leads me to, so basically we can say, what do we see out there right now? I'm putting this together on July 9th. The Atlantic's a little bit warmer than average. It's not exceptionally so. What would be a year that was a lot warmer that you can recall in the tropical Atlantic? And, to kind of contrast this to, it's a little bit warmer now. Well, what was a year where it was a lot warmer?
Yeah. 2020 was somewhat warmer. 2010 was extremely warm. 2017 was also getting quite warm by this time. Another reason why we really started ratcheting the numbers up in 2017 as we got closer. There certainly have been years that have been warmer early on. So, at this point, the tropical Atlantic certainly isn't as warm even as it was last year at this time. There are some indications we may see the warming continue at a faster rate than normal, because obviously the tropical Atlantic in the northern hemisphere always warms up from spring to summer, but this year it looks like it may warm up a bit faster than normal. In terms of what we see out there right now, the next couple of weeks look pretty quiet. There's some sub-seasonal so there's kind of things that drive hurricane activity on a seasonal level, and then there's things that drive it on a shorter term level. And we do forecast during the peak of the season for that as well. And those environmental conditions look less favorable for the next couple of weeks. So it looks like the next couple of weeks probably will be fairly quiet and potentially more conducive conditions as we get into late July, early August. But, we need to remember that even if, say, nothing happened the rest of July, over 90% of your major hurricane activity occurs after the 1st of August. So while June and July is a third of the hurricane season in terms of calendar days, it really doesn't ramp up until August. And Bill Gray used to ring a bell on August 20th every year, signaling the active part of the season. And there's a lot of years where you look to August 20th and you may have had one hurricane, maybe no hurricanes, but that's about time things really ramp up. And for example, if you think about the Atlantic, August 15th, on average, the Atlantic has had one hurricane. Sure. So, if we had no hurricanes until August 15th, no additional ones, we'd still be dead on average. So, if say the last couple of weeks are quiet, which looks fairly likely, doesn't necessarily mean that, these seasonal forecasts are out to lunch or that everyone overblew it. You have to really wait. August, September, and October is really the meat of the hurricane season in general. And then obviously we had a year like last year where it just kind of seemingly went on and on. And November was ridiculously active too. But normally August, September, and October is really the heart of the season.
What causes the deep tropics to warm like we've seen in some of those years? 2005 was pretty warm. 2010 was, I remember that one. What causes that? Why do those waters warm? Why don't they just stay a certain, static temperature? What the heck? I mean, what causes that in a nutshell?
Yeah. So obviously, you have kind of the seasonal cycle where you get warming, every summer, but the years where it warms faster than normal, there's a couple of factors. One is that often if, say, for example, you have an El Nino the previous winter, when you get an El Nino, what happens is you tend to get more sinking in the Atlantic, more sinking, more drying. So you actually basically get more sunlight, basically less clouds, so more sunlight hitting the ocean. That tends to warm up the ocean. So for example, 2009 was an El Nino year. And early in 2010, I remember just looking at the sea surface temperature anomalies or differences from average. And it was like bright red over the entire Atlantic. And it was super hot. And 2010 was a year that was a very active hurricane season. We had 12 hurricanes in the Atlantic, but 0 landfalls. It was just really good luck effectively that year. Last year was really bad luck. 2010 was really, really good luck. So there's kind of that El Nino that can cause it, but also too, if your subtropical high pressure system in the Atlantic is weaker, that basically means you're going to end up with weaker low-level winds blowing across the tropical Atlantic. And if you have weaker winds, you get less mixing and churning up of the ocean surface, and that also leads to warming. So that's something we monitor on a week-by-week, month-by-month basis in the Atlantic. For example, the next week or so, it looks like the subtropical high should be a little bit weaker, so we'll probably see more of this anomalous warming or warming faster than normal in the tropical Atlantic. Once you get beyond about 2 weeks, the forecast and the models just aren't very good, so it's really hard to say. But at least at this point, indications are that we should see the waters, which are right now just a little bit warmer than normal, potentially warming up at a faster rate. Another thing we watch closely this time of year is kind of what the vertical wind shear or the change in wind direction with height in the Atlantic is like. It had been pretty high through about early to mid-June, and then since then it's really, really dropped. One of the reasons we got Elsa was we had generally pretty low shear. It does look like the shear is going to come back up in the next couple of weeks and then potentially go back down. So that's why we usually lose like a 30 to 40 day average, because something like shear can be pretty volatile. Sea surface temperatures tend to be a little more like they'll go up and down, but they tend to go up and down on longer time scales. There's more kind of basically inertia. It just takes a lot more to change the ocean temperatures than it does to change the winds in the tropical Atlantic on a day-to-day basis.
Well, speaking of El Nino, we're officially, if everybody got the alert, under a La Nina watch. I thought that was interesting. Happened yesterday, I think, coincided with the forecast coming out from you and your group there. But that's a real thing, that the Climate Prediction Center has issued a La Nina watch, that there's the potential for this La Nina, the abnormal cooling of the tropical Pacific. That's how unusual is it? We had one last year, a La Nina, and maybe another one coming into the fall a little later than we started last year, but that could play a role into this, maybe dragging the hurricane season more active into October, perhaps, Caribbean systems?
Correct, yeah. And so last year is a great example of what La Nina seasons can be like. So last year, obviously, we had 30 storms, and we had by the end of September, we had 23 storms. So we were, we're already second most on record for that. And so people thought it was a super active season, but through the end of September, we'd only had 2 major hurricanes, which is pretty much close to average by the end of September.
True.
But in October, November of last year, they upgraded Zeta. So we ended up with 5 major hurricanes in October and November. The most October, November major hurricane formations in any other year have been 2. So the record was 2. We had 5 last year. Wow. So that was insane. I never knew that.
I didn't realize that. Of all the stuff that's come out, I didn't put 2 and 2 together. That's remarkable.
Yeah. So it was just, and it was, one right after the other. And so, when we did our seasonal forecast in August or at the end of September, I was really worrying that we had basically not, from a verification perspective, thinking we had undershot. We had overshot the season. The number of storms forecast was good, but we had forecast 12 hurricanes, and 5 major hurricanes. Yeah, 5 major hurricanes, and we were at 8 and 2. So I said we're going to be way over on those numbers, and we ended up being under, which I would never have thought October 1st. And so late last season we had a La Nina, so the shear was much lower than normal. And also we had a very warm Caribbean that hadn't been tapped really until October. So there was all this area of water that was 87, 88 degrees, which is basically rocket fuel for hurricanes. And we saw, we had Gamma and then Delta and then Zeta and then Gamma, Delta, Zeta, and then Eta and Iota. We had 2 other we had Epsilon and Theta out in the open Atlantic, but those 5 in the Caribbean, and especially Eta and Iota were just monster storms, obviously causing tremendous damage in the Caribbean.
Yeah, it was weird being in Louisiana. We were there at the end of August for Laura, then we're right back again there in October, near the anniversary of Michael for Delta, and then darn close to Halloween for Zeta. I was like, this is just unbelievable. My birthday is in early November. And then right after that, down I go to Florida for Eta, 2 weeks before Thanksgiving. It's just like,
Yeah.
wow. And so we could attribute that part of it to the La Nina that developed in the Pacific.
Correct. Yeah. And so it's not uncommon to get what they call a double dip La Nina, where you'll get La Nina, it'll kind of go back to neutral, and then it'll dip back to La Nina. So there are actually indications in the next few weeks that the wind, basically the low level winds in the tropical Pacific, should be conducive to potentially trending things more towards La Nina. And it's funny, even I put out the forecast yesterday, and in the forecast talked about how we expect neutral end zone. Like, I probably should have talked up La Nina a little more than I did in there. So I think we do one final update in early August, and we'll probably talk up the chances of La Nina a little more. And so we also monitor another index, which basically looks at El Nino, La Nina, but instead of looking at, so the NOAA basically monitors like this one box in the tropical Pacific. And if that box is half a degree Celsius warm or half a degree Celsius cold, they say El Nino, La Nina. And this one kind of monitors more like the overall large scale circulation of the atmosphere. And that index is still in La Nina. And we're kind of tending to see that overall circulation too. I mean, in general, the Western Pacific typhoon season has been pretty quiet. It was especially the last few weeks. Eastern Pacific's been pretty quiet as well. And so that's more typical of a La Nina, like basically La Nina like environment. So we'll see, obviously, if they officially meet the La Nina criteria, but don't necessarily at this point expect to see a La Nina that was as healthy as last year's, but there is still that potential. We could see the season drag on more until October into November. Hopefully not as crazy as we saw last year, where I think Louisiana was hit by hurricanes. It was like every 24 days or something from like mid-August on, if you count Sally as being a near miss to Louisiana.
Yeah, we got to know a lot of Cajuns last year, that is for sure. And they were awesome people, let me tell you what, but they just assumed they didn't keep seeing me over and over.
Yeah. You're becoming like Cantori. Like, come on.
Right. Oh, he's coming with those yellow boxes again. Are you kidding?
That's right.
I'm sorry. Yes. All right. So the MDR, I've always wondered this. I see a lot of talk about the main development region. It gets a lot of emphasis. It's a little cooler than average sometimes. And people are looking at CDAS temperatures versus the NOAA coral reef, which used to be the NOAA NESDIS, and the MDR. So some years, like 2005, Katrina, Dennis, Emily, and Rita and Wilma didn't track through the MDR as hurricanes, if I remember correctly, at least the eastern MDR from the Caribbean islands to Africa. That's generally what I think of as the MDR, although I think you take it all the way over to like 85 west, if I'm not mistaken. But those were big impacts that didn't come all like Ivan or, Gloria or whatever. Is there too much emphasis placed on the MDR overall? If the MDR is dry or not active, then the hurricane season is not going to do much.
Yeah. And so, so I guess some of it is how you define the MDR. So I usually basically separate the tropical Atlantic at 60 degrees west and say basically the lesser and greater Antilles. So basically anything east of that's the tropical Atlantic, west of that's the Caribbean. Okay. Those two boxes combined, I consider the main development region. And so a lot of these systems, say, for example, last year is a good example where we didn't have a lot, we had Teddy that was the one long track storm right off Africa that went all the way across, went up and gave some stormy weather to Canada, but not really that big of a deal. But last year, if you look, we had 14 hurricanes last year. And I believe all but one of them actually formed from an African easterly wave. Even Eta and Iota in November came from easterly waves. Right. So they didn't necessarily form in the eastern and central tropical Atlantic, but they made it into the Caribbean where the environment was much more conducive, and then they ramped up. And, similarly, Dennis and Emily, Dennis, I think, formed east of the islands. Emily was a little farther to the west, I believe. But like Katrina, Rita, and Wilma also all formed from, I believe, Katrina was like a hybrid easterly wave and then some upper level feature, I believe. But like a Wilma also was like an easterly wave and then interacting with kind of that low level Caribbean gyre, which is basically a little area of Caribbean spin that sometimes shows up in October, November, which was there a whole lot last year. So I think it's important to monitor that region, because between the tropical Atlantic and Caribbean, I think like 85% of your major hurricanes originate in that area. Okay. You can get storms forming at higher latitudes, right? Especially if you also include the Caribbean. Right. So I tend to look, obviously I look at both. But when I monitor things like vertical wind shear, I look at from like the Caribbean all the way east to just off the coast of Africa and try to monitor it in that region. The Caribbean actually is the region that actually tends to have the highest predictability associated with it. And also if you monitor the winds in that region, that actually is the area that correlates best with overall Atlantic hurricane activity. And I think it's because it's tied not only to what's going on in the tropical Atlantic, but also has the strongest tie to El Nino, because El Nino goes on in the tropical Pacific, and where those thunderstorms are there is how it then increases the upper level winds that tear apart hurricanes, especially in the Caribbean. So if you look at El Nino versus La Nina, you look at hurricane frequency, check the Caribbean. That's where you get your strongest signals. And obviously last year, great case in point, a heck of a lot of activity late in the Caribbean, whereas in an El Nino year, generally almost nothing in October, November, especially in the Caribbean.
Makes sense. All right, couple more points before I let you go. Where do you see this going? Hurricane seasonal, sub-seasonal, the art of this, the science of it, 5, 10, 20 years down the road. You're a young enough guy. I knew you when you were even younger, and you've done a lot. Your team there and the legacy of Colorado State began, of course, with Dr. Gray. So where does this go? And how does machine learning and who knows what, is there a way to know, or do we just not know what we not know and we hope for the best?
Yeah. Well, guys, so as Donald Rumsfeld said, you have the known unknown, the known unknowns and the unknown unknowns. And I mean, so I think, with seasonal forecasting, you're never going to be able to say June 1st, August 12th, a hurricane's going to slam into Florida or North Carolina or something like that. But I think, where it's going, what we're doing a lot of work on is we're working on a lot of what we call hybrid modeling. So where we use climate models, such as the European Center model, the Met Office model, to forecast the large scale environment. So basically use a climate model and say, what do you think the shear is going to be like in August and September?
Gotcha.
And if the models actually have, these climate models have historical data that they're based off of, so you can actually verify and see how well have these models actually forecast these things. And you can build models off of that. So we have kind of the Bill Gray old school approach of statistical modeling, whereby you use, for issuing a forecast June 1st, what does April and May look like? Okay, we know what April, May looks like this year. How does that compare with April, Mays of the past of active seasons versus inactive seasons? So that's one way you can do it. And we still do that. But then you can also use these climate models to forecast the environment for, say, 1 month out, 2 months out, 3 months out. And the models, they're not perfect, but they actually do have reasonable levels of skill. And we've been incorporating, and we're incorporating some of that into it as well. And so I think, one of the areas everyone wants to know is, where's the Bermuda High going to set up? How are the storms going to be steered?
Sure.
That's so volatile day to day, week to week, month to month, that it's really hard to predict that. But one thing I think we can do a little better on is trying to predict where the storms are likely to form. And if you know, for example, you're going to get a season like 2020, where you're going to have, the Western Atlantic is going to be super conducive and everything's going to form there. Basically, that means somebody's going to get walloped, because whether it hits the US, Caribbean, Central America, someone's going to take it on the chin. So that's obviously something, if you could, have we been able to say August 1st last year, hey, we're going to have a very active season. It looks like it's mostly going to be in the Western Atlantic. That would obviously have been a huge help. So I think that's something that we're going to be working on a lot, is trying to basically better improve forecasting where the storms are more likely to form. And I think there's some stuff we can do there. So there's a lot of those kinds of avenues that we're working on. I think machine learning may be able to help, not necessarily on forecasting seasonal levels of basin-wide activity, because that area has been looked at by a whole lot of people using a whole lot of different techniques. And basically, I've done a little bit of work with some colleagues on that. And when they run the machine learning, it basically picks out what Bill Gray said 35 years ago using pen and paper, which is good. I mean, it says, that these techniques work, but it's a matter of trying to, but I think maybe with some more of these like formation zones and things like that we don't know as well, that might be useful. One of the things I think with machine learning is trying to really basically dial down the confidence of the machines. The machines will say all these different areas are very important. They tend to maybe be a little bit overconfident. And we ran into that at CSU in the early 90s, where we had a lot of predictors. We overfit our various schemes and they didn't work very well in real time. So now when we do our forecast, we use fewer predictors, try to boil it down to really what we think is really most important. And usually with our models, it's maybe 3 or at most 4 predictors, as opposed to, there was one point where we had like 18 or 20, and that's just was too many, and it was overfitting the data. So I think with machine learning, it's trying to use some of that too. So working with a couple of colleagues at CSU, trying to play around with some of the machine learning stuff too. So hopefully next few years, there may be some more of those kind of approaches that we're using as well. And again, we're not the only show in town. There's over 20 other groups doing seasonal forecasts, and they're using a variety of different techniques. And then somebody somewhere may come up with some, groundbreaking approach that blows everything else that we're doing out of the water.
Right.
But again, I think with basin-wide numbers, I think that's not necessarily there's a whole lot more we can do there, but I think there's a lot more we can do maybe we're trying to forecast where storms are more likely to form. And I think one of the last things we're trying to do is basically with these climate models is our August statistical model is really, really good and has really good skill, but basically trying to say, can we use a climate model to forecast those conditions a month earlier? So basically, can we get August skill in July, July skill in June, June skill in April, basically trying to improve that skill further out to get more lead time. So I think that's really where we're trying to head with a lot of this stuff.
Fascinating. I'm telling you, I mean, it's come a long way. It'll be interesting to see where it goes. It's helpful to people. More so than they think. People like to scrutinize it. Everybody's an expert on Twitter and YouTube events and elsewhere. But at the end of the day, it really, you got to start somewhere. And as I was saying in my update today, my video discussion, Bill Gray, well, let's just call it 40 years, roughly, rounded up, call it 40 years this has been happening from him. And that's a drop in the bucket in geologic time, doesn't even count. And so we have a long way to go. And the observations are getting better. The computing power is getting better. There's more smart people out there now. So that's good. That'll help. Really interesting stuff. So lastly, I love the sports context to stuff. It kind of helps people to understand and visualize, something that they can relate to. So we call it the keys to the game. And, we be careful that we know hurricanes are not a game, and we certainly understand that. But the analogy there going forward, sort of, like you would get Dick Vitale or somebody talking about a big game coming up in college basketball. What are the keys? Duke and Carolina, here we go, or whoever it is. Being a Tar Heel native, I'm a Duke fan. I know college basketball, and we look at the keys to the game. Going forward, what are the keys to the game that we would look for as sort of the audience here between now and November 30th?
Yeah, I mean, so I think one of the things we talked about earlier, that La Nina potential, obviously, if the tropical Pacific cools quite a bit and we go more towards a La Nina, that could potentially make for a more active season. I mean, I'm going to be monitoring very closely. Right now, it looks like the shear the next couple of weeks is going to be pretty strong in the Atlantic. And I think that's more of a subseasonal thing that will basically go away. And then we replace with lower shear for more like early August when, overall the environment generally is more conducive. But obviously, if that shear were to stay up higher, that would obviously potentially mean towards a lower season. So we would do issue a final update in early August. Sure. And there's a lot of information in July data. So the tropical Atlantic kind of locks in whatever mode it's going to be in during July. June doesn't necessarily mean a whole lot, but July means a lot. The shear the first week in July was very low. And so what we do is one of the things we monitor is like 30-day average shear. So basically so right now it's like, it will be like June 10th to July 9th or whatever. And then, that keeps getting updated. And so if you look at the correlation today, it's like 0.5. So explain about 25% of the variability. If you do it like 2 weeks later, it's up to like 50% of the variability in these integrated ACE metrics for hurricanes. So there's a lot of information in July data. So that's something we're going to be monitoring very closely, as we get ready to put out our final update in early August. So yeah, I'd say really kind of monitor what's going on in the Atlantic. But again, subseasonal, like the next few days, probably the Atlantic's going to look like basically if you want hurricanes, it's going to look like garbage. Like it's going to be very dry, a lot of shear, almost nothing out there. It doesn't mean that, the season's done. Not every season is going to be like 2020 where it's like seemingly there was one right after the other and there were almost no breaks. But I do have to say, even last year, we went from about September 20th to 30th with no storms. It was extremely quiet. The Atlantic looked extremely harsh. And I, having had forecasts that looked like it was going to be too high, was really wondering if the numbers were going to actually end up verifying. And then early October came around and things changed. So things can change pretty quickly. So I would say kind of monitor what's going on in the Atlantic, keep monitoring the Atlantic Ocean water temperatures. yeah, and basically just, keep a weather eye to the sky. And then obviously if these storms do threaten, to follow the advice of the National Hurricane Center, and especially your local emergency managers, because they're the ones that really know your community the best.
Yep, there's a lot of info, a lot of people talking about it, myself included, on social media and elsewhere, a lot of voices. But at the end of the day, Phil is right that National Hurricane Center is our authority in the United States, and National Weather Service, your local officials, et cetera. They know what's going on and they follow this stuff. It's important to them. It helps them to plan. It's great work. I appreciate your time this evening to talk about all of this. Again, kind of a deep dive, as deep as we can do here. Like you said, we could talk about it for hours and hours. I think a lot of people would sit there and absorb it for hours and hours, but I appreciate your time this evening. Any other thoughts before you go, even if it's not related to hurricanes? You've been hiking out there in Colorado, opening the chips at 50,000.
Yeah. So every time we climb a 14,000-foot mountain in Colorado, we bring a can of Pringles with us that's come usually from like 5,000 or 6,000 feet, and then open it up at the top and do the pressure change.
Yep.
You would sometimes get a lot of chips flying out of the can. Of course, we eat all the chips because you don't want to leave any trace.
Right.
But we've had up to about 20. But the last time when we climbed Mount Evans, which is like 14,200 feet, made a loud noise, but was a complete dud. So alas, but I think tomorrow or Sunday, there's another fairly high peak on the agenda. So we will bring a can of chips and see if we can get some chips to fly out of the can up there too. But not every Pringles can is filled the exact same height. So some seem to be a little bit short stacked. So if those are short stacked, then you don't get as much. You get a lot of noise, but not necessarily so many chips flying out of the can.
Right. What do they say? It's sold by volume, not weight, or something.
Correct. Yeah. So and I think it also depends too where the can of chips was made and how long it had stayed at various heights along the way. So sometimes you can tell when you get to the top, you get the nice big puff up, and then it's they're gonna probably fly out. So
what we should do in our weather balloon project, the Herbie, maybe when our testing one year, is we'll put a can of Pringles, some of those short stacks, in front of the camera, and those go up to the stratosphere at 100,000 feet, and just watch it explode.
Yeah, that would make for very good entertainment purposes.
Then it'll rain Pringles down across some countryside. Some guy will be outside, and
that's right.
Frozen Pringles will rain down on him. And if they get in a thunderstorm or something, they could become condensation nuclei for hail-shaped Pringles.
That's right. You could have hailstones that formed that condensed on a Pringles chip. So
you never know. Well, cool. Well, be safe out there in the hiking. At least as a meteorologist, you know how to avoid the lightning, because you'll be one of the tallest objects out there on top of that mountain. So be careful, but have fun nonetheless. And
thank you.
Thanks for joining me for this edition of Hurricane U, Phil. Really appreciate it.
Thanks, Mark. Take care.